This video introduces and explains Energy on Demand system developed by Matsuyama Laboratory, Kyoto University. This system allows users to set energy consumption limits without sacrificing quality of life. First of all, I'd like to explain the basic concept of this system. To set up energy on demand system at homes, offices, and factories, we installed smart taps which allow us to measure and control electrical power for all electrical appliances via a wireless network. When an electric appliance is turned on, the smart tap starts operating. However, power is not supplied immediately. First, the smart tap wirelessly transmits a power request message to the power manager, providing information on the priority and electricity required for that appliance. The power manager then determines the available power supply based on the daily accumulated power limit and upper limit of maximum instantaneous power by time, which the users set in advance. If the required electrical power falls within the two limits, the power manager sends a power available message to the smart tap, and electricity is supplied to the appliance. Meanwhile, when the power required exceeds the limits because of additional power requirement, it will be cut off or reduced to low priority appliance, including appliance that is being operated at the time, to automatically adjust power consumption to keep it within the limits. Energy on demand system can keep both the accumulated power and maximum instantaneous power within the limits set by the user, and automatically control the power supply to electrical appliance according to individual priority. This system allows users to set energy consumption limits without sacrificing quality of life. Matsuyama Laboratory developed a smart apartment to evaluate the effectiveness of energy on demand system. Let's take a look at some examples of the system in the smart apartment. This is an actual smart apartment. In this apartment, all of the electrical appliances are equipped with smart taps to measure electrical consumption and control some of the home appliances. These are the smart home appliances corresponding to our energy on demand system. These smart home appliances were created by modifying existing home appliances and attaching a device which can be controlled by the network we developed. Energy on demand system uses Power Manager to control smart home appliances and other home appliances equipped with smart taps to ensure more efficient energy use. Let me explain the Power Manager. Please look at these graphs. The graph above shows changes in instantaneous power. The far right shows current. As you move left, the older figures are shown. Red line shows maximum instantaneous power, green line shows the power usage plan, and the blue line shows power consumption throughout the entire apartment. The graph below shows the transition of the accumulated power consumption. Green line indicates the power usage plan, and the blue line indicates accumulated power consumption actually used. The right portion of the screen shows power supply adjustments based on the power requirement information received from smart home appliances. The data above shows current power supply adjustments, and the data below shows past power supply adjustments. Let's take a look at the system under actual living conditions. Let's assume that the power usage is set for 800 watt. We get home now and turn on the light in the hallway. Before it turns on, however, the light tells the power manager that it requires 145 watt, and the power manager sends a message of permission to use required power. In the same way, we turn on lights in the living room and bedroom. As is shown, smart home appliances can be controlled by smartphones. Next, when the air conditioner is turned on, it tells the power manager that it requires 500 watt. This brings the total power consumption beyond the planned value, 800 watt. In response, the power manager dims the bedroom light, which has a lower priority, to allow use of the air conditioner. When the TV is turned on, it tells the power manager it requires 145 watt. The power manager responds by adjusting the TV screen brightness setting to reduce the requirement to 105 watt, and adjust power to other lights to the maintained value set by the power usage plan, 800 watt. Next, we turn on the hot water pot. It also exceeds the planned value of 800 watt, so the power manager places a temporary hold on power to it. Looking at the priority of the hot water pot shown below left, we can see the priority of the hot water pot gradually increases. The priority reaches maximum after a certain waiting time. When this happens, the TV and air conditioner, which now have lower priorities, are adjusted along with the hot water pot to allow power supply to all three. At this moment, power consumption throughout the entire apartment temporarily exceeds the planned value, but not the maximum instantaneous power. In the end, total accumulated power consumption does not exceed their planned value. This scenario is for an emergency power-saving request in normal life. The maximum instantaneous power at this time was 1,500 watt, with the TV and lights operating under normal conditions, and the air conditioner set at 26 degrees Celsius. An emergency power-saving request was received. Maximum instantaneous power was reduced to 1,000 watt. Then, to prevent power consumption from exceeding the limit, the power manager adjusted the TV screen and lights in the bedroom and living room. Their air conditioner setting was changed from 27 to 28 degrees Celsius. Executing these operations on home appliances can reduce the power consumption in blue line to below the limit of the maximum instantaneous power in red line. In energy on-demand system, although an emergency power-saving request is received, the air conditioner does not always to be turned off. Peak reduction can be achieved by eliminating lower priority power. We are planning to verify the effectiveness of energy on-demand system in single-family dwellings, offices, and factories. In addition, we are planning to develop a system that maintains comfort under further significant power reduction through introduction of rechargeable batteries into energy on-demand system. Through the wide dissemination of this energy on-demand system, we believe it is possible to help society use limited resources more effectively and flexibly. We will continue devoting our efforts to research, development, and practical utilization.